In this lesson, we're going to talk about the phones. In the circuit diagram, we see eMMC or eMCP and some UFS for mid to high-end machines. This code on the drawings actually refers to hard disk circuits. We say that ROM is equivalent to hard disk of a computer. ROM was called read-only memory in the early days. With the development of technology, it can also write data. ROM is abbreviated as Phone Library on Android phones, usually called hard disk phone library, which stores the bottom-level data of the mobile phone, such as boot programs, system programs, user data, and baseband data. For example, the one selected in the box on the right is SEC, which is Samsung's phone library. There are problems with these boot programs in the phone library, which generally cause the machine to fail to boot and directly enter the COM port mode. It needs to be divided into platforms. Mobile phones using Qualcomm platform enter the 9008 port. MediaTek's port mode is called MediaTek USB port. HiSilicon's port mode is called Huawei USB COM 1.0. That is to say, there is a problem with the phone library of these three platforms, or there is a problem with the boot program in the phone library. Sometimes it will enter this state. But if we want to see this state, we must plug the mobile phone into the laptop or desktop computer through the data cable. And it will automatically appear in the Computer Management Device Manager. You can see that it will jump out of corresponding port mode. System programs problems sometimes also cause the stock logo, unable to enter the operation interface. Let's take a look at what stock logo is. This is Huawei's mobile phone. Then it stays on the Huawei logo when it is turned on and cannot enter the operation interface. We call this phenomenon the stock logo. Problems with user data will lead to the loss of customers' data and the inability to enter the operation interface. Problems with baseband data will result in no baseband, no car recognition, no serial number, and no network. We can read and write the phone library through the test stand. To sum up, these are some failures caused by the boot program in the phone library, the system program, user data, and baseband data. The current common phone brands are as follows: Samsung, starting with SEC, Hynix, starting with SKHY, SanDisk, and Toshiba. Let's take a look at the comparison of the transmission speed of eMMC and UFS, the mainstream phone library of Android phones. From this comparison chart, we can see that there are two types of phones we currently use. One is eMMC and the other is UFS. Generally, the eMMC phone library is used on low-end and mid-end mobile phones, and the UFS phone library is used on high-end mobile phones. That is to say, the speed of UFS will be faster than that of eMMC. In this picture, we compare UFS 3.0 and eMMC 5.1. As you can see, their speeds are different. eMMC is a simple phone library, just hard disk, and UFS is also simple phone library. The eMCP is launched on the basis of eMMC. How can we understand this eMCP? It is eMMC flash memory plus control chip plus running memory. That is to say, eMCP has low power memory in the phones at the same time. They are integrated. From the appearance, it is a chip. Then the eMCP appeared in the later development of UFS. eMCP is actually a chip containing a found UFS, a DDR5 generation running memory, which is the mainstream memory of Android mobile phones. Okay, that's it for our lesson.